Okay, example 5. At noon, ship A is 190 kilometers west of ship B. Ship A is sailing east at 45 kilometers per hour. Ship B is sailing north at 35 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Okay, so when you start having vehicles moving in directions, what you want to consider is, are they moving parallel, perpendicular, that kind of thing, maybe opposite parallel, that kind of stuff. Ship A is going east and ship B is going north. So we got east and north, those are at right angles to each other. If things are at right angles, you should expect a right triangle to show up. All right? So your goal in this picture is, I want a right triangle to show up. Okay, you got to put everything where they belong, but expect a right triangle somewhere. And you want your dimensions along those lines of being in a right triangle. So if we take a look at the original scenario, there's a line that's east-west line right there. It says at noon, ship A is 190 kilometers west of ship B. So let's put ship A right here. And we'll put ship B right here. And we know for a fact that that distance is 190 miles. Okay? Now, I put 190 there because that's exactly where they were. Okay? The fact that they were exactly 190 miles apart at that moment in time at noon, 12 p.m., that's the exact distance apart. That's not going to change. Okay? They're going to move, so they're going to move from where they're at, but the fact that they were exactly 190 miles apart at noon is not going to change. That's where they were at noon. Okay? So I went ahead and put 190 on the front. Okay? All right, and the final statement says that we have to worry about 4 p.m. So what I want to consider first of all is, how far will ship A go? All right, how many hours is ship A sailing?
4.
4. And how fast is ship A going?
45.
45 kilometers per hour. So we know, and this is kilometers here, right? 190 kilometers. Okay. If I do 45 times 4, this is rate, this is time, this will equal distance, right? 45 times 4 is 0, carry the 2, 180 kilometers. Okay? What that tells me is that at 4 p.m., ship A will not be beyond ship B's original position. Ship A is traveling this way, but it matters. They're talking about 5 p.m. Now ship A is beyond ship B's distance. Okay? It matters as far as where variables are going to be located. So I know that ship A at 4 p.m. is going to be somewhere around here. This is ship A's position. Bless you. And I know ship A is going this direction. So if this is the path of ship A right here, this blue line. All right? Again, my goal is to make a right triangle. So we have to consider that when we're making all this stuff up. Next, ship B is sailing north. Okay, ship B is off the map now, right? He's going this way, so it doesn't matter how far he goes to begin with. It matters about ship A because maybe they pass where ship B was, maybe they don't. So it matters to me what side of ship B that ship A is on. But ship B is going north. It's going to be going north. So it's going north, and this is its path. And it's going, and this is where ship B ends up, right?
Yep.
This is B start. This is B end. This is A end, and this is A start. All right. Looking at this picture, and again with the idea of I want a right triangle, the question asks, how fast is the distance between the ships changing at 4 p.m.? So their concern for us is, how fast is that changing? That's what their concern is. A is moving this way, B is moving that way. This distance between them is changing, right? Both ships are moving, and that distance between the ships is also moving. All right? So, consider this, that obviously this is a right triangle, right?
Yep.
Here's what I want to get across to you. I could put X here, how far ship A traveled. This will be 190 minus X. Or I can put X right here, and that would be 190 minus X. It doesn't matter how I go about doing it. What would be easier to work with? Would it be easier to work with X or 190 minus X? What?
190 minus.
You think 190 minus X is easier to work with than X?
No.
No, probably X. Right?
Yeah.
X is probably easier to work with. So let's stick an X right here. That would be how much distance is left, right? And then let's call this Y. That's how far ship B is moving. And let's just call this over here Z, just because X and Y are used, and that's the next letter in the alphabet. No special tricks there. Z is fine. I can use x or 190 minus x. It doesn't matter. But what does matter is I'm dealing with that right triangle. That's what I care about. All right? Now, looking at this and considering the fact that I need to know that x equals something, y equals something, and z equals something, and dx over dt and dy over dt and dz over dt equals something. All right. These are the boxes I have to fill in, and of course I have to get a relating equation. Let's start with the relating equation because that's easy. What's the relating equation?
X squared plus b squared equals c squared.
Or in the case of this one, since we're using x minus z, x squared plus y squared equals z squared, right? We have a Pythagorean theorem. Right triangle, Pythagorean theorem. It just, as soon as you see right triangle, expect the Pythagorean theorem is going to be coming along. Especially if you're dealing with the three sides. If you're dealing with angles and right triangles, now you might use some trigonometric function or like something like that. But if it's just the side measures of a right triangle, Pythagorean theorem is typically your thing. Notice I'm given two speeds. It's very important that you see that. Ship A is sailing east at 45 kilometers per hour. Ship B is sailing north at 35 kilometers per hour. That's two different rates, right? Given two rates, I'm allowed to do a third rate. All right. You're always allowed to use one more variable than the number of rates you're given in the problem. So that's why I was comfortable putting three variables in this picture. Now, what does x equal?
10.
How do we know that?
190 minus 180.
We've already established that ship A will have traveled 180 kilometers in that 4 hours. They started off 190 kilometers apart, so x is left to be 10. Had we called this x and this 190 minus x, now this is x is 180, right? And this is 190 minus 180, which is still 10, but now we got to work 190 minus x in our problem. So again, anytime you use single letters instead of a binomial is much better. What does y equal?
We don't know.
Well, we can figure it out, though, can't we?
Figure it out, yeah.
Ship B is sailing north at 35 kilometers per hour.
35 times 4.
And times 4 hours is equal to 140. Is
That's what I got.
that what you got, 140?
I did it in my head.
Excellent. Proud of you doing it like that. That's a good job. All right. Is there any way in the world we can figure out what z equals?
Not yet.
No, maybe we don't need to. And if for the fact we might not need to, let's just go ahead and skip that. Do we know what dx over dt is?
45.
45. Should it be plus 45 or minus 45?
Minus.
Why is it minus, Tyler? Just feels like it should be minus, right?
Yeah, I got it.
Just feels like it. All right, look at the dimension x in the picture. Okay, see how I've drawn it, right? This is x, this is 190 minus x, right? And again, we made the decision already to put x right there. All right, looking at the picture, is x getting bigger or smaller? Smaller, so it's negative. If we had put x here and 190 minus x there, then dx over dt would be positive 45. So depending on how we draw the picture, it could be a positive or negative. In this case, based on our picture, x is getting bigger. X is getting smaller, so we get a negative 45 kilometers per hour.
The way you asked it, I kind of assumed.
I'm sorry.
So,
Try to ask better next time. Suppose this had been like 200. Now, this is beyond that, right? So now x is getting bigger. So now dx over dt would be positive. So again, look at your picture, how you've got it drawn. Here's my dimension x. If the ship continues moving as it's moving, x is getting shrunk. Therefore, dx over dt is a negative number. What about dy over dt?
Positive 35.
Positive, very good. Looking at y's dimension, there's y's dimension, right? And as ship B continues to move north, y is getting bigger. That's a positive 35 kilometers per hour. We're using good notation here, kilometers per hour. Of course, we don't know how many kilometers per hour this is, but we'll figure it out. Kilometers per hour, what's that about? Kilometers per hour. And this is 10 kilometers and 140 kilometers. Just look at the relating equation. Is z going to stick around? When we differentiate, take a look at it. If you differentiate that, will z stick around?
Yeah.
Yeah, well, so let's go ahead and figure out what z equals. So, x is 10, so we get 10 squared is 100. And y is 140, y squared will be, was it 19600?
sounds good.
Is that what you got when you did in your head, Tyler?
Yeah, that's what I
That's
got.
good, all right. Equals z squared, so we get 19,700 is equal to z squared. So z is going to be the square root of that number. I don't know what the square root of 19,700 is.
Oh.
Tyler probably does. Square root of 19,700. Calculator does.
It's on 40.3.
That 140.3567. Said 3567. 3567. All right. We go 4 decimal places. 140.3567 kilometers. Almost exactly the same as 140, right? Which seems reasonable because we're almost here, right? So those should be close to the same number, but not quite the same. All right. So now we've got our box filled in with all 3 variable values. We've got 2 of our rates. We're looking for the third. We have a relating equation. We're at the point now where we're ready to do our calculus, differentiate with respect to t, substitute everything in to figure out what dz over dt equals. So, and yesterday what I told you with the Pythagorean theorem is this: when you differentiate 2x dx over dt plus 2y dy over dt plus 2 or equals 2z dz over dt. What you can expect to happen, 2, 2, 2. And whenever the Pythagorean theorem shows up, there's a bunch of 2's usually. Canceling the 2's is legal and just gets things a little smaller. It's worth doing. Okay. And each one of those is just a basic function, x squared, y squared, z squared, so they're just all simple derivatives, 2x, 2y, 2z. None of them is t, so they're all d the letter over dt necessary in each one of the derivatives. At this point, I know x, I know dx over dt, I know y, I know dy over dt, I know z, I do not know dz over dt, so if I substitute everything I know in, what's left is what I'm looking for. So 10 times negative 45 plus 140 times positive 35 is equal to 140.3567 times dz over dt. So all you have to do to get the answer is take all this stuff, right, and divide it by that, 140.3567. All right. At this point, I just go ahead and enter my calculator. So notice I've got a product and a sum of products on top over a single number. So if I want to type in that expression exactly as it's written, I put parentheses first. And then I just type in the entire top. So 10 times negative 45 plus 140 times positive 35 in parentheses. Now the top is done. Divided by 140.3567 equals, we end up with 31.70 kilometers per hour. Okay, so imagining this and thinking about the validity of this answer, y is going straight up at 35 miles an hour, right? Or 35 kilometers per hour?
Yes, sir.
The fact that x is moving closer to it as he moves out is deducting some mileage per hour from that, right? But not a lot, because it doesn't function much. There's not a lot there. Okay, if we were back here maybe after 1 hour, then it would probably be a lot less, because then the x would influence it more than the y. All right. So as far as the speed between the two ships changing, y is much more influential than x at this point, so it's positive 31.70. All right. That means that that distance between them is increasing at 31.7 kilometers per hour at that moment in time. Again, if we were much closer to A's original position and much closer to B's original position, now x is affecting it more, right? So then it's probably decreasing at that moment because x is decreasing. All right. And again, I could have done it the other way with x being here and 190 minus x being there. It would have all worked out. This would have been 180 instead of 10. This would have been positive 45 instead of negative 45. This would have been 190 minus x. We would have had to differentiate. It would all work out in the end, but it would just be a lot harder to deal with. So if you see that a right triangle is going to happen, do everything you can to make just single letters show up in the right triangle. And one other thing I want to mention to you that happens quite often, 3 letters happen more often than not. But sometimes one of those sides is set in stone. So maybe this is always 10, this is changing and that's changing. Or maybe this is 140, this is X, this is Z. So
It's the
sometimes
difference, yeah.
one side doesn't move. Maybe ship B is just sitting there, you know? Ship B got there and just stopped, all right, stopped engine. Now, dy over dt is 0, all right? So, and, it really matters in that scenario too. So that's something else you need to look at when you're doing these problems. But anytime you get right angles or things at right angles, you have a diagonal involved, you're trying to make a right triangle out of it, expect that to happen. And related equation being the Pythagorean theorem, try and get letters, single letters as your sides if you can make it happen. Sometimes you can't, but try, okay?
Pretty good.